So in this video we'll go through our logs solving and also the indices solving. We'll put some tags down in the links below. So when we start with this one, we can't really do much with it in log form, so what we're going to do is we're going to move it over into indice form or exponential form. So we'll go in as 5 to the power of 3 equals x plus 2. So remember that log form is just the same as index form but written in a different way. So it's the base to the power equals basically. So once we've got it into this form, what we'll do is we'll expand our indices. So 5 to the power of 3 is 125. And on this side we've still got x plus 2. And now we're just balance methoding to solve it. So it tells us to plus 2, so we'll take 2 from both sides and we'll end up with x being 123. The second one's similar. We can't do much with it while it's in this format, so we'll move it into index form. So this time we've got x, a base of x to the power of 2, funny looking 2, and that equals 196. And we're back to balance method. So we need to get rid of that square by square rooting both sides. That'll leave us with x and the answer 14. When we get to question C, we need to start using our log laws. So you'll need to go to your formula sheet, and what we can see in this one is it's got a subtraction in it, and also the base numbers are the same. So we can use the second law to make this one work. And the second law tells us that what we're going to need to do is take this number and divide it by this. Okay, so when we write this out, it'll now look like this. Log to the base 2, 2x plus 1 divided by x minus 1. And I've just popped that in brackets so it doesn't fall apart at the moment for us. And that still equals 4 like it does in the equation above. But now that we've got it this far, we can't really do much more with it unless we move it into index form. So this would give us a base of 2, an indice of 4, and the answer is now 2x plus 1 all over x minus 1. And so now what we can do is we can start to expand and collect this. I'll show way more working out than what you need, okay? But this would be 16, and now you've got 2x plus 1 all over x minus 1. And so now it's balance method. Multiply up by x minus 1 on both sides. And so again, too much working out, you could jump a step here, but it will become 16 times x minus 1 equals 2x, that's not a minus, it's just the pen mucking around, 2x, wow, 2x plus 1. Okay, expand, and then we'll just shift all our x's left and shift all our numbers right. So now we've got 16x's minus 16 equals 2x's plus 1. And we'll start shuffling everything around. So let's take 2x's from both sides. We'll get left with 14x's minus 16, and on this side we'll get left with 1. Now we'll add 16 to both sides. We'll end up with 14x's on this side, 17 on this side, divide by 14 both sides, and you'll end up with x equaling 17/14. So question D is really similar. If you have a look at it, the keys to this are the base numbers are both the same, and we've got a subtraction, so we're going to use the same rule as what we did in question C. So in this one, we rewrite this as log 4, so we've got a base of 4, and this time we've got 2x divided by 5, and we can see that that equals 3. And so now what we'll do is we'll move it into index form so that we can work with it. So we've got a base of 4 to the power of 3, that equals 2x divided by 5. And now we'll just start manipulating it. So 4 to the power of 3 is 64. That equals 2x divided by 5. And we're just up to balance method now. So let's times by 5 both sides. What we'll end up with on the left is 320. And on this side we'll have 2 x's. I only want one group of x, so we'll divide by 2 both sides. And we'll end up with x being 160. And that one's been solved as well. We're not solving for x this time, we're just simplifying these as far as we can. So with the first one, we can see that this one will work with the fourth log law. So the fourth log law, we know these base numbers are the same, and when we've got a division like this, we just rewrite it. So lean on your sheet to get the formatting for this so that you get all of the numbers in the right spots. The answer to this one, when we start to simplify it, just becomes log now to the base number 5, and that comes from this number here, 625, obviously from this number here. And then if we can do something to solve from here, we will. So what we'll do is we'll manipulate this, make this log 5 to the power of 4, and then if we use one of those log manipulations, we can then move that 4 out the front of this. So this one becomes 4 log 5 to the 5, and we know that log 5 becomes 1, so this is just the same as 4 times 1, which is 4, and that one's taken as far as we can. B, let's have a quick look at this. When we have a look, it's got base numbers that are the same, and it's an addition, so it'd be nice to be able to use the equations that we've got for these, but we can't do that while we've got a third out the front or a 2 out the front. The equation doesn't allow for that. So what we need to do is we need to do the opposite to what we did in the previous question, and we need to move them up as powers. So with these ones, we can rewrite this so that we've got log 10 64 to the third, okay, and remember that's really the cubic root of 64, just written in a different way. And then we've got log 10 5 squared. And so what we'll do is we could use your calculator if you wanted to do the basic ones. Otherwise, we've got the cubic root of 64, which is actually, before we go any further with that, which is 4, and then we've got log 10 to the, oops, that's a 25, 5 squared is 25, and now that it's in this format, we're allowed to use that first log rule. So that means that really what we've got here is we've got log 10 to the 4 times 25, or log 10 100. And rather than stop there, I know that 10 squared is 100, so I know we can take this one just a little bit further. So what we can do here is we can say, okay, and I'm just running out of room, so I'll just start up here. I've got log, it's really not cooperating, this pen, 10 squared, and we know we can take that little 2 out the front to make it 2 times log 10, or 2 times 1, which is 2. Question C won't work in its current format with our log law, so we'll have to manipulate all three terms in this. This one's unique because it's got this 1 sitting on the end over here, or -1 sitting on the end. So let's have a look at tidying this up. What we can do is we can modify this to read log 3 to the 36 to the power of a half, or the square root of 36. We've got log 3 to the 4 squared. And then that -1 on the end, we know we could write this as log 3, like that, and that would make -1. And now what we can do is we can start to tidy it up a bit. We've got log 3, square root of 36 is 6, 4 squared is 16, and we've got our term that we don't need to modify any further on the end. And now what we can do is we can start to use the law. So let's break it into two, and let's look at the addition portion of it first. So using our first law, we know that this will give us log 3, 6 times 16, which is 96. And then we'll take log 3, 3 from this. And so now we know using law 2 that what we've given ourselves now is log 3, 96 divided by 3, which will be log 3, 32. It looks like without a calculator, that's as far as I'm going to be able to go. All right, next, let's have a look at this one. We could better write this. Let's have a look at putting this one in as 2 log 10 2 to the power of 3. And we could run that over log 10 2 to the power of 4. And because we've managed to make these the same here, we're going to be able to simplify it from here. So that 3 is going to have to get multiplied by the 2. So what we'd end up with here is we're going to end up with 6 groups of log 10 2 divided by 4 groups of log 10 2. They'll eliminate one another. So really what I'm looking at is 6 over 4, which is equivalent to 3 over 2. That's my final answer. Right, we'll have a look at indices. So in the first example, we've got brackets. So when you've got brackets, you're multiplying your indices. So you have to remember that if there's not one there, there's actually a little 1 sitting up there. So sometimes it's helpful just to chuck it in so you don't forget. So now what we're doing is we're just multiplying across the indices. And I should mention as well that there's a little 1 here above the 2. Often people forget about that and they don't end up applying the indice to the number, and it's really important that you do that. So now what we've got is we've got r to the 3 times minus 2, so it becomes r to the -6. Then you've got m to the 1 times minus 2, so it becomes -2. Then I've got 3 to the now power of, sorry, I've got 2 to the now power of 3 because it's 1 times 3. So we've got, and we'll leave it in like that just in this line, but normally I just immediately make that an 8, okay? But so it's nice and clear. Then we've got r to the 4 times 3, so we've got r to the 12, and then we've got m to the 2 times 3, which is 6. And then all I do is I just run along the line, and it's a bit like collecting like terms. So deal with the number first. 2 to the power of 3 is 8. It can go straight out the front. Everything else is a 1, so we'll leave it as it is. We'll start collecting your letters. Do it in whatever order you want. I tend to do it in alphabetical order just so that I don't stuff anything up. But I go m to the -2 plus 6 makes 4. And then I've got r to the -6 plus 12 makes 6. And when I get to these points, usually what I do as well is I just double check. And the question says writing it with negative indices when necessary, it doesn't mean that you need to turn this into negative indices. Don't do that, okay? It just means if the answer turns out to be a negative, don't stress out about it, okay? There's no need to manipulate it. In the next question, you'll notice that it says writing your answer with positive indices, then you must manipulate it so you've got positive answers. Question 2 uses a more typical kind of set of index laws. There's a couple of ways of doing these. The only thing that I'm going to point out with this one straight away is don't muck around with the numbers, okay? Leave the numbers where they fall. So when I start this one off, the very first thing that I do is leave the 2/4. You could simplify it straight away to a half if you wanted to, but just run across the top, collect up your numbers, run across the bottom, collect up your numbers, and then what I have a tendency to do, some people like to collect them and work vertically up and down, and some people like to get them all up in one line. The bomb-proof way of doing this is to get them all up in one line. So you can collect a few if you want along the way, or you can just string them all out in the first instance. So I'll just string them all out just for argument's sake, so it's nice and clear. M to the -3, C to the 1. I'm going to put a 1 in there so I don't forget about it. M to the -5. I've got C to the 2. So I've just worked across the top row there. And now what I'm doing is I'm working across the bottom row and bringing them up. And as I bring them up, I'm just going to switch the symbol. So C to the -5 becomes C to the +5. M to the -2 becomes M to the +2. And now what I'll do is I'll do the first simplification. So the fraction can become 1/2. And there is a 1 here, but I know that's ultimately going to disappear anyway, so I probably wouldn't bother writing it. And no harm in having it there. And then I'll go across my C's because I like to keep things in alphabetical order. So I've got 1 plus 2 makes 3. 3 plus 5 makes 8. So I've got C to the 8. And then I've got M to the -3 -5 makes -8. -8 plus 2 makes -6. And I can leave this question as it is because it's got a negative indice, but it's told me that that's fine. This time we're simplifying indices again, and we're doing it with a positive answer. And these ones are unique. So something that we didn't learn last year in 9 Extended was that if the indices are the same, we can multiply the bottom numbers. Last year we told you that the base number always had to be the same, but that's actually not the case. So here we could rewrite this and manipulate this so that we can apply that rule. So here we've got 2 to the power of n, and then we've got 2 to the power of 3. And if you're wondering how it is that I'm allowed to do that, remember that in our original index laws here, what would happen is if we multiplied those numbers, we'd be adding the indices. So that's why we're allowed to split it off like that. Then we've got a 5 to the power of n. And if we bring that 3 up, we've got a 3 to the power of positive n as well. So straight away I can see that that one, and that one have all got the same indices. So that means that their base numbers are allowed to be multiplied together. So that would look like this. 2 times 5 makes 10. 10 times 3 makes 30. 30 to the power of n. And then I'm left with 2 to the power of 3, which is 8. All right, and in question B, we're going to need to use our index laws again. There's 2 complications with this. The first one is that it's got square root symbols in it, which isn't going to be very helpful, and it's not very friendly working with division. So what we're going to do first is we're going to get rid of the square root symbols, so we've got it in index form, and then what we're going to do is we're going to get rid of that division and make this a times, because the multiplication is much easier to deal with. So in this case, the square root of x is the same as writing x to a half. No triangle. Y to the 2. And we've got y to the 3 halves. and we've got x, and this is really x to the 1. Now, you can skip this step, but I'm doing it so it's clear. So this next step is where you could jump straight to. I want to turn that division into a multiplication, and the way that I do this is by flipping this upside down. So the second one gets flipped just like any fraction. So when we write this out again, we've now got x to the half over y2 multiplied by x to the 1 y to the 3 over 2. Be really careful here. This is where people are likely to make a mistake by switching symbols when they flip it. Don't do that. We're not moving these values up or down. When we flipped it, that's only to deal with the division, okay? So they don't become negative or anything like that. Just leave them as they are. And now what we're doing is we're just multiplying or adding across the row. So now we've got x to the power of 3 on 2 all over y to the power of 2 2's 4 plus 3 is 7 on 2. You could rewrite this one as the square root of x cubed all over the square root of y to the power of 7, but I don't see why you'd necessarily need to, but either answer should be acceptable. Right, question 3, we've got indices that lead to logs. So this time, instead of hunting for an x that's a base number, we've got x's up in the indices. So what we need to do is we need to try and make all the base numbers the same. So we're going to manipulate the number 1 and the number 32 to give them a base of 2. And the way that we can do that is we can say, we know that 2 to the power of nothing is equivalent to 1. So we're going to change it into that. And we can leave this one the same because it's already got a base of 2. And then 32 could also be written as 2 to the power of 5. And now that we've got, that shouldn't be an equal sign, we can make that a therefore. So now that we've got base numbers that are all the same, if we think about our index laws, if we're dividing numbers, we know that we'd normally subtract their indices. So if we disband all of the base numbers and we just focus on the indices, what we've got is we've got nothing minus 2x equals 5, okay? Now obviously that 0 doesn't need to be there, so really what we've got is negative 2x is equaling 5, and now we're just down to balance method. Let's divide by negative 2 both sides, and x is negative 5 over 2. So we got negative 5 halves. And remember that's fine too, because if you've got an indice of negative 5 over 2, you've got one of those square roots of whatever the number is to the power of 5, and the negative just makes it a fraction, so it's the denominator. All right. Last one. So same sort of deal here. What we have got is we've got 3 numbers that have got different bases, and we're trying to solve into the indices here. So let's make them all bases of 5, and we can start from there. So we know that we've got 5 to the power of 2 is 25, and what we'll need to do is we'll need to multiply the existing indice by that 2 that we've moved up. That's all over 5 to the power of x plus 1. I'm going to chuck that in brackets just so it doesn't fall apart on me. And then over here, I've got 125, so that's the same as 5 to the power of 3. And I'll multiply that by the existing indice. All right, and so now that I've got that into a semi-friendly format, because this is by no means a friendly question, it's the same indice rule as what we've got last time. We're going to do this one minus this one equals this one, okay? So let's just take the indices, let's just ignore the 5s now, we don't need the base numbers anymore. And I'm going to be really careful about how I write this out, okay? So I'm doing this in a very specific way. This is why I used brackets. I've now got 2 x minus 2 minus x plus 1, and this is why I've left it in brackets, that way I won't mess up any of my negatives, positives, and that's going to equal 3 times 2x plus 3. And here, from here on in, I'm ignoring that I'm doing anything to do with indices at all. This is just a nasty expand, collect like terms and solve. So here we've got 2x's, we've got minus 4. This is the bit that people could potentially get wrong. We've got minus 1 times x makes minus x. We've got minus 1 times 1 makes minus 1. So we've got to make sure they're in. This is the catch that's trying to trick you in this question. And you've got 3 times 2x makes 6x, 3 times 3 makes 9. And now we're just going to go about collecting like terms. So I've got 2x minus x makes x. Minus 4 minus 1 makes minus 5. On this side, I've got 6x's and 9. We talk a bit about smart choices. Doesn't really matter at this point, but I'll take x from both sides and keep all the x's positive to save me a step later. I've got minus 5 here, and I've got 5x's plus 9 over here. This time I'll subtract 9 from both sides. So I'll end up with minus 14 over here, 5x's here. And then I will divide by 5 both sides. And so my final answer is that negative 14 fifths is equal to x.